Very good morning to everybody. Thanks a lot for the invite and also the introduction from David. Very happy to be here. I think that everybody, enjoy the sharing by Alvin and also Mark. Okay, that is truly insightful and inspiration. Today, I'm very happy to introduce about the evolution and also the prediction for the XR technologies, together with some of the applications. I will not go through too much about myself, okay, because I think that David just mentioned. There is a little bit update that now I sit on the advisory for another new company, okay, and also I was also invited to join the editorial board for 2 new journals, okay. On the right side, okay, this shows the media exposure that I have been invited in the past 15 years around, okay. So looking at that, okay, fortunately I feel that still I have the hair on my head, all right, okay. Yeah, so I feel that Alvin and Mark, they have give great presentations about, the vision and also the directions for VR and AR and also XR technologies. So I will be more touching about the ground, okay? Starting from the introduction about, where VR and AR started, and also some of the applications that my team has conducted in the past few years. And then I will go a little bit into the depths about some of the key enabling technologies for XR technologies, like the display, the tracking, the interactions, and also the content. At the end, I will also share my personal perspective about on the ground what are the technological kind of direction for the next. All right. So let's start. There are many different things about when and where this VR and AR started. So in my opinion, I think that there is one system that has been commonly recognized as the start of VR and AR technologies. That is back to 1968, when Dr. Alan Sutherland, he invented this, this head-mounted 3D display. At that time, actually, the word VR, AR were not coined at all, okay? And the product is named the Sword of Damocles because it's something like, it's a very pole, over the head, and also it's in very bulky size, okay? It shows, okay, what the VR and AR prototype look like. Although the content is very simple, it's just some kind of, 12 single frames, okay? So this is the picture that Dr. Alan Sutherland, he gave a keynote speak in Singapore back to 2016, talking about his 16 years of computing. This photo was taken by me. Okay, of course, I just own the copyright. So very much inspired by his talk, and also he received this Turing Award in 1983 for his contributions to the HCI, VR, AR, and also in the silicon technologies. All right. Every day, we have heard about the VR, AR, metaverse, or XR technologies. Okay, and also in the market, there are different types of the system available. I think that we are very happy to have this kind of systems, like HoloLens, like Apple Vision Pro, like HTC. Okay, and also Magic Leap, Meta, of course. Okay, and also the X-Ray, and so far. I was very fortunate to personally try a collection of those historical XR headset when I was attending this year's VR conference in Orlando, okay? And also at the beginning of this year when Apple's Vision Pro was first launched for sale, I was invited by, I think, Terrence from Celio. I'm not sure whether he's here, okay? So to have a personal experience about the Apple Vision Pro, yeah. So these are some of the history about the VR and the AR, okay? And in the past few years, okay, my team have been working on how to apply these technologies for different kind of applications. Just for example, we have worked with one of the I think the public transport vendors in Singapore, SMRT, I believe that some of you take the public transport MRT coming to this expo, right? So we developed two systems, one using VR and one using AR to help to train the operational staff on how to troubleshoot the problem with the MRT cars, or how to start some kind of engines, all right? So one of the projects is also in collaboration with Terence from Saleo, all right? And also we work with a art and performance-related company to use these smart glasses to provide these closed captioning solutions for the people who have the hearing problems, okay? So the idea that, for example, I'm standing here giving the talk or giving a performance. So in case there are some people who cannot hear me clearly, all right? So they could just pick up these smart glasses, and those captions will be automatically showcased into their eyes. And this will not interfere or impact the other people's viewing experience, okay? And also my team works with one of the social enterprise to work on a MR enhanced training program for the people with some kind of mental problems, because we feel that those people, although they are suffer from some kind of mental disabilities, they still hope to have gained some kind of a basic life skill set. So that's the reason that we provide this MR training system for them, such that they can, at least they know how to prepare the fast food like a sandwich or some other simple food, okay? This is another platform that we have developed together, okay, that allow for the multiple users collaborative interactions with virtual content together, okay? So the thing is that you can just easily drag and drop, okay, any kind of 3D models or 2D pictures or the virtual images, whatever, into the system, and then the multiple users, they are able to immediately start to interact with this virtual content. The last is a very simple demo, all right? So this is just a starting of a project. I worked with Immerso. I think Matthias are you here? Okay, with Immerso, and also Inder Jiang from Harvard Lab, okay? So just a few of my FIP students, so they work with the two companies and try to use this VPS system for the navigation kind of applications, right? Okay, so these are some of the applications that my team has done in the past few years, and also I introduced about the history of VR and AR. So from my perspective, although now we have different kind of products, okay? So they are very, very advanced, okay? They provide some needs. But if we compare what we have today with what has been done back to 1968, the key enabling technology still remain almost the same, okay? So that includes the display. If you look at all those things, for a VR and AR application, there should be a display, there should be some content, and also tracking, and also the interaction. Okay, so those are the some of the research work that is done by my research team, and I will just go through each of one of them. Okay, maybe some of them is starting from the early days. Okay, just for example, this is my first touch with VR. Okay, back to 2003. At that time, we were using the active shutter glasses. Okay, and you can see here. We managed to find a CRT monitor that is able to support up to 60 hertz frame rate, right? And some of you maybe also have the experience about the immersive, big immersive setups, just like a cave, okay? So this is another product that we worked with. We worked on this immersive room, okay? And that shows a virtual volleyball playing game, right? And also, we worked with ETH Zurich, okay, to develop a solution for the polarized transparent 3D display. So the thing that the people, they still need to wear the 3D glasses, all right, okay. But we at that time we were thinking, why not that we think about some solution that just take out the glasses. I think some of you heard about this, glasses-free 3D display or auto-stereoscopic display. So at that time, there is another term. It's called the live field 3D display. So basically, try to simulate, where the light come from, okay? Whenever that you move around, okay, so the light will project to your eyes, okay? So this is a light field display. And then I think that after this light field 3D display, we also start to look into the so-called the display for the VR and AR headset. In the technical term, it's called near displays, okay? So for example, some of my students, okay, it's just a FIP students, final year students. So they came out with the idea, now they don't have the money, okay, to buy, thousands or at least a few $100s of headset. So they were thinking about, whether that could be a more cost-effective way for them to learn how the VR and AR works, okay? So they came out with the idea, try to break down the basic structures of the VR AR headset into something that can be 3D printable, okay? So those are the things that are 3D printed. And the raw cost for every headset is just, less than $10. Of course, don't expect this to work as equally as something like, like a HoloLens or the Apple Vision Pro, okay? But I believe that the students at least they know how the basic principles of VR, AR works. And they even give the name like VEGO and also DIA, okay? VEGO stands for VR Lego, and the DIA stands for DIY AR, okay? Of course, these are just some kind of cool or interesting products, okay, my students undertook. So we are also looking at something that is a little bit more technology advanced. For example, in 2019 to 2020, we tried to use a tunable lens into the VR and AR headset, okay, such that it can help to solve the problem, the so-called avoidance accommodation conflicts. The reason being that, at that time, for most of the VR and AR displays, the virtual images is always in focus, okay? That is sometimes is against how our eyes, okay, perceive the real world, okay? So that's the reason that we try to use the tunable lens that can dynamically change the focus of the virtual images. But the thing is that we encounter a challenge over there. Okay, I can share with you. The tunable lens, if you put just in front of our eyes, it can refocus or adjust the focus of the virtual images. But at the same time, it will also change the focus of the raw images. That is not something that we hope to achieve for the AR displays. So how we solve the problem? We use the shutter glasses, okay? So we choose the time multiplexing solution. So which means that at one single frame, we open the image for the virtual image source, okay? And then we try to turn on this tunable lens, okay? At this frame, we block the image from the raw environment. And then at the next frame, we open the image from the raw environment, but we also close the image for the virtual image. So by doing this, okay, we can just swap real and virtual. And then for the virtual images, we are able to adjust the focus. Okay, so this is what we achieved. Throughout this process, we realized, okay, it is not easy to achieve the VR, AR, and AR displays that features, for example, full color, compact form factor, large field of view, at least 90 degrees and above, okay, of course, and also lightweight, okay. So because if we look at all the, waveguide, okay, freeform, optical combiner, those technologies, none of them, they are able to meet all those requirements. So there are some kind of breakthrough technologies. So we start to look at, the hologram, okay. It is called holographic near display. The idea is that we can print, okay, a piece of a hologram film, all right? So which normally is transparent, and it is less than 1 mm thick, okay? And also it can provide up to even at least 80 or even to 100-degree field of view, all right? So then we did give a try, all right? So you can see from here, okay? So this is what we developed a prototype. So this actually is just a simple transparent glass paste it with this recorded hologram, and then we are able to achieve this is a virtual image, all right? So the thing is that the hologram, once printed, it is static. So it does not meet the requirement for showing the dynamic content for the VR or AR. So how to solve that issue? There is the so-called spatial light modulator, okay, that will dynamically modulate the incoming laser point, all right, laser information, and try to generate the 3D hologram data for the virtual images, okay? So we are happy to have some kind of progress from there, okay? But research is like that, you know. After we go deeper and deeper, we figure out, okay, there are two major limitations for this holographic near display. The first one is the eyebox, okay? The reason being that when you record the hologram plate, okay, so from the laser signal, right, there is only one single fixed focus point, okay? So which means that when your eyeball is located at that position, okay, you are able to see the full image. But if you move your eyeball to another place, another position, okay, you will lose or even completely cannot see anything. All right. So this is also called the limited eyebox for the holographic display. So how to solve the problem? We tried different means just to share with you. Okay, we thought about different ideas. So one of the ideas that why not we just record a multiple kind of focus point for this hologram plate, all right? So whenever that your eyes move to a position, okay, and then your eye will be able to perceive this image, all right? But still, there is some problem, okay? So what is the problem? You can imagine. What if that your eyes just sit in between the two focus points? So which means that your eyes will receive double images, all right? So this is not what we hope to achieve. So we are working on something using the so-called steering mirror, okay? So we track your eyeball, okay? And then we try to adjust a very fast moving mirror, okay? That will dynamically change how the input laser light, okay? And thus we can control how the image will go into eyes, all right? So this is something that we are still working, but we're very happy to see that we have achieved a full color holographic near display, all right? So this is the latest work, all right? And also, I mentioned there are two key challenges, right? So this is the one, the limited eyebox. The second one is the computing, because in order to generate the 3D hologram for holographic near displays, the computing process in the normal ways is very time consuming. Normally for one single frame, it takes about 2 to 3 seconds, which is not something that we hope to achieve, okay, for real-time performance. So how to accelerate? We thought about, we come up with the idea, why not we just use the AI, okay? So we train a neural network, okay, with a number of those input images, the target images, and we generate the hologram, okay? Once the network is trained, for a randomly given kind of a target image, we are able to generate this hologram. And this is also something that we have achieved, okay? All right, so that is about the display, right? So 4 technologies: display, second is the content, right? So I believe that there are a number of professionals, experts here, okay, using the 3D Max or Maya or Blender or some other kind of solutions. So I will not talk about that because that is also a very big topic, okay? So, and also I think today we can use some kind of scanners, okay, to capture the environment. For example, on the left, I think on your left side is the point cloud that is captured by my students using the 360-degree cameras. But what I want to see that, I think that in about 3 to 4 years ago, okay, there is a new technology that is empowered by AI. It's called the NERF, Neural Linear Field technology, okay? So basically that you just take a video of the 3D environment, and then with the AI, it can try to reconstruct the view, okay, and also give you some kind of a high quality visual effect, okay? At that time, the speed was also a bottleneck, okay? I think quite a lot of researchers, okay, they start to investigate how to accelerate this process. I think that at the end, the rendering, I think that especially like NVIDIA, and also some other kind of research works. So at the end, the rendering of this pre-trained network can achieve even faster than the real-time performance. Okay. In the past 2 years, there is another new or promising technology, so-called Gaussian splitting. Okay. So this is, by the way, okay. This nerve is a birthday cake for my PhD students, jointly supervised with NVIDIA. Okay, so this is the result from that, and this is also the Gaussian splitting result from my lab. Actually, this is one of my labs in my university. All right. Okay, so. No matter it is, use 360-degree cameras or use nerve or Gaussian splitting, still they are scanning-based kind of 3D data generation. And everybody now talking about generative AI. So whether this can also be applied for the 3D models, the answer is yes. Okay. So this is a work that last year my students attended this IEEE CNE. Okay. For the cross-reality competition. I think Mark was there also, right? Okay, so the idea that, the student just talk to the mobile phone and say, okay, give me a chair, okay? And then the chair will automatically generate it, okay? And also, on top of that, he can also talk to this mobile phone to say, I don't like the chair's color, I want to change the color, okay? And this will automatically done by the AI. So this is a demo.
Red.
Yep. All right. Okay. So of course, we can do more complex things generation with AI. Okay. But there is, along the research work, okay, we also figure out that there is one challenge. It happened to generate generative AI, not just for 3D, but also for 2D. Okay, if you don't try, you can just give it a try. Okay, just to see that. Okay, what is the problem? The problem is that if you want the generative AI model to give you some precise number of objects, okay, they give you some kind of a very weird result. Just for example, I want to have 5 chairs here. Okay, you give this kind of input to the AI models. Sometimes it can give you 4 chairs or 3 chairs, or even can give you a chair with 5 legs. All right. So we realize this problem, and that's the reason that we start to figure out, okay, if there could be one solution. And the answer is yes. We have a good news that we just submit the paper to SIGGRAPH Asia, and this is about how to generate the precise number of instances for 3D models with just a text input. And this is a video. So you can see, give me 6 chairs. Okay, this command sent to the server, and then it will generate 6 chairs. Very precise. We tried 5 chairs, 4 chairs. Okay, so 10 chairs. Okay, so this is something that has been generated. Okay, so last slide is about the localization and tracking, right? So everybody know about the SLAM, right? And what we are currently investigating is that there is one common problem with some of the localization and also tracking solution is that it's about how to detect where the starting position of the this VR and AR. Okay, so especially if there is a very limited information. So what we are now looking is we just use a mobile phone. Okay, take a few photos, and then we are able to understand where is your current location, especially if you just have a floor plan of this room. Okay, so this is something that is ongoing. Unfortunately, I cannot share with you more detail about this one. So I think that I have maybe one minute, right? So some of my view, I think that a lot of things share in common with what Elvin and also Mark shared. Okay, the first thing that for the near display, okay, I'm very excited to see a lot of, quite a number of exhibitions showing the display technology over there at the exhibition hall. So that is very exciting. But my personal view that if we want to have something just like eyeglass, we can wear, just few hours a day, okay? and we have the full color, wide field of view, compact form factor, and also the lightweight. I think there is still some challenge there, okay? So this cannot be easily resolved, okay? So this could be some kind of opportunities for industry and academia to put effort inside. Second thing that the boundary, I mentioned there are 4 technologies, right? Okay, enable technologies, display, content, interaction, and also tracking, right? So if you look at them, okay, actually they all leverage on the computing, okay? So thanks to the AR technologies, I think that the boundary between these kind of pillar technologies are becoming blur and blur, okay? And also another thing that the boundary, like Mark shared, called the cross reality. Virtual image, virtual content, the real world, okay, the boundary are becoming more and more blurred, okay, or more and more merged together. Last but not least, we know about the spatial computing, and now there is there is also another term, spatial intelligence, and also recently there is a hot topic, is about the physical intelligence, okay? So I resonate with what Alvin mentioned, okay? AI can empower VR and AR, but on the other hand, VR, AR can also help AR technologies, all right? And especially for the physical intelligence, something like, embodied intelligence in the robots, all right? So I think that is all what I want to share with everybody. Thank you so much. Thank you.